Dear students, in this presentation we are going to discuss about spread spectrum in detail. In telecommunication and radio communication, spread spectrum techniques are methods by which a signal, it could be an electrical, electromagnetic or sound signal generated with particular bandwidth is deliberately spread in the frequency domain, resulting in a signal with a wider bandwidth. These techniques are used for a variety of reasons, including the establishment of secure communications, increasing resistance to natural noise, and jamming, to prevent detection, to limit power flux density, and to enable multiple access communication. The outline for this presentation is shown here. So in this session, we will see in detail about spread spectrum, its types, and also its uses and applications. Spread spectrum generally makes use of sequential noise-like signal structure to spread the normally narrow-band information signal over a relatively wide-band radio band of frequencies. The receiver correlates the received signals to retrieve the original information signal. Originally, there were two motivations, either to resist enemy efforts to jam the communications, anti-jam or abbreviated as AJ, or to hide the fact that communication was even taking place, sometimes called LPI, low probability of intercept. Frequency hopping spread spectrum, abbreviated as FHSS, direct sequence spread spectrum, abbreviated as DSSS, time hopping spread spectrum, abbreviated as THSS, chip spread spectrum, CSS, and combinations of these techniques are the various forms of spread spectrum that's available now. The first two of these, that is FHSS and DSSS, employ pseudo-random number sequences created using pseudo-number generators to determine and control the spreading pattern of the signal across the allocated bandwidth. While the standard IEEE 802.11 uses either FHSS or DSSS in its radio interface. We have seen the various forms of the spread spectrum. However, it's important for us to know the generic types of spread spectrum signals. There are four types, which are direct sequence, pseudo-noise, frequency hopping, linear frequency modulation, which is also called as a chip. The first one is the direct sequence, in which the carrier of a DS source stays at a fixed frequency. Narrowband information is spread out into a much larger bandwidth using a pseudo-random chip sequence. The next one, which is called as pseudo-noise, is where the pseudo-random sequence is referred to as the spreading code or a pseudo-noise sequence. The energy of the signal is equally divided among different frequencies. Frequency hopping, uh, or also known as frequency hopping spread spectrum, is a method of transmitting radio signals by rapidly changing their carrier frequency among many distinct frequencies, occupying a large spectral band. FHSS is used to avoid interference, to prevent eavesdropping, and to enable code division multiple access communications. The final one, which is called as the linear frequency modulation or chirp, is a signal in which the frequency increases, which is called as up chirp, or decreases, which is called as the down chirp, with time. In some sources, the term chirp is interchangeably used with sweep signal. It is commonly applied to sonar, radar, and laser systems, and to other applications such as in spread spectrum communications. Now let us try to appreciate what is FHSS. You can also see the diagram over here, which has the three dimensions where we have time, power, and frequency. And you can also see the desired signal hops from one frequency to another. Now, FHSS is a method of transmitting radio signals by rapidly changing the carrier frequency among many distinct frequencies, occupying a large spectral band. The changes are controlled by a code known to both transmitter and receiver. The frequency hopping spread spectrum technique uses m different carrier frequencies that are modulated by the source signal. At one moment, the signal modulates one carrier frequency, and at the next moment, the signal modulates another carrier frequency. The frequency hopping spread spectrum is a method used to rapidly switch transmitting radio signals among several frequency channels. The FCC has certain regulations in place in which RFID readers must comply in order to transmit 1 watt of output power. The next form is the DSSS, which is also called as the direct sequence spread spectrum. In telecommunications, direct sequence spread spectrum is a spread spectrum modulation technique primarily used to reduce overall signal interference. The DSS modulation makes the transmitted signal wider in bandwidth than the information bandwidth. The DSSS transmission employs a chipping code to spread the transmission over a wide frequency band than it would normally occupy. The direct sequence spread spectrum technique expands the bandwidth of the original signal. It replaces each data bit with n bits using a spreading code. The spreading of the information is performed by using a spreading signal called the code signal. The code signal is independent of the data and is of a much higher chip rate than the data signal. Time hopping is a communications signal technique which can be used to achieve anti-jamming and low probability of intercept. It can also refer to pulse position modulation, which in its simplest form employs discrete pulses, referring to the unique positions of the pulse within the transmission window, to transmit bits per pulse. To achieve low probability of intercept, which is also called as LPI, the transmission time is changed randomly by varying the period and duty cycle of the pulse using a pseudo-random sequence. The transmitted signal will then have intermittent start and stop times. Although often used to form hybrid spread spectrum systems, TH is strictly speaking a non-spread spectrum technique. Spreading of the spectrum is caused by other factors associated with time hopping, such as using pulses with low duty cycle having a wide frequency response. In digital communications, CSS is a spread spectrum technique that uses wideband linear frequency modulated pulses to encode information. In the image is an example of an upchip in which the frequency increases linearly over time. As with other spread spectrum methods, this CSS uses its entire allocated bandwidth to broadcast a signal, making it robust to channel noise. Further, because the signals utilize a broad band of the spectrum, this CSS is also resistant to multipath fading even when operating at a very low power. However, it is unlike DSS or the frequency hopping spread spectrum in that it does not add any pseudo-random elements to the signal to help differentiate it from noise on the channel, instead relying on the linear nature of the pulse. Additionally, the CSS is resistant to the Doppler effect, which is typical in mobile radio applications. The spread spectrum communications are widely used today for military, industrial, avionics, scientific, and civil uses. The applications include jam-resistant communication systems. So in the image, you will see the devices and the diagrams which actually show the jam circuits. The next primary application of the spread spectrum communication is in the CDMA radios. It is useful in multiple access communications, wherein many users communicate over a shared channel. Here, the assignment of unique spread spectrum sequence to each user allows him to simultaneously transmit over a common channel with minimal mutual interference. Such access technique often simplifies the network control requirements significantly. The next application which we are going to discuss is the high resolution ranging. So spread spectrum communications is often used in high resolution ranging. It is possible to locate an object with good accuracy using SS techniques. One example where it could be used is Global Positioning System, which is known as GPS. Here, an object can use signals from several satellites transmitting the spread spectrum signals according to a predefined format to determine its own position accurately on the globe. The next application is the WLAN, which we are all familiar of. The wireless local area networks widely use spread spectrum communications. IEEE 802.11 is the standard that is developed for mobile communication and widely implemented throughout the world. The standard defines three types of physical layer communications. These are infrared communications, direct sequence spread spectrum communications, and finally the frequency hopping spread spectrum communications. Among the three, DSSS and FHSS are widely used. Cordless phones implement spread spectrum by several manufacturers. The advantages of using spread spectrum in cordless phone include the following points: security, immunity to noise, and longer range. So security, it is achieved because a SS communication is always coded, and SS modulation is immune to noise when compared with other modulation schemes such as amplitude modulation and frequency modulation. And finally, due to noise immunity, it is possible to achieve a longer range of communications for a very small transmitted power. And you can also see the long range wireless phones for home and industry, which play a vital role. And of course, you can also see the cellular base stations interconnection. This was a quick session. With this, we come to an end. However, it is important for you to do this discussion forum activity. Now, there are various important spread spectrum terms that we came across during this presentation and also the previous presentations. Now, I want you to research these terms and post the definition of each in the Blackboard discussion forum. There is a Blackboard discussion forum which is created for you to submit the solutions for this activity. Please note that this is a graded activity and you will be able to see the sample solutions once you have posted your answers. Thank you. Once you have posted your answers in the Blackboard, you're free to leave, and that's all for today. Thank you for listening.